I'm Neel Kunjur. I'm the CTO co-founder of K2 Space. Along with my brother, I co-founded K2 back in June of 2022, and I run the engineering teams here. Since my time at SpaceX, where I worked on the Crew Dragon program pretty extensively for about 6 years, I always intrinsically knew the importance of telemetry and the ability to consume, access telemetry, and how it leads to successful engineering organizations. So when we started K2, that was one of the first and most important things I wanted to make sure we incorporated was this DNA or fabric of telemetry throughout the company. And Sift, being built off of telemetry was a really important tool to bring in the fold. My first engagement with Sift was actually back when it was being beta tested. So I knew Karthik at SpaceX and the team, and I got to interact with it pretty early on, and I was really impressed just with the maturity of the product, the ease of use, how intuitive it was, and then the feature roadmap that Karthik had planned even back 2 years ago to make it even better. So when we started using it, it already had all the basic features that we were looking for, and we've been really excited to see it grow since then and get more and more integrated into how we do operations here at K2. Yeah, so to be honest, at the time we were considering Sift or doing it ourselves. Those were really the two options that we looked at. And Sift, being a team of people that I'd worked with before, being built in a way that a lot of the team at K2, who mainly hails from SpaceX, is used to, it was just a very natural choice to use that tool, continue to invest in its growth rather than building that ourselves. My goal has always been anybody from the technician to the CEO is engaging with telemetry, and can do that on a daily basis if they so choose. Sift's really enabled that because it's very easy to integrate with a lot of our test infrastructure that we're building to do automated tests, automated checkouts of everything from components to fully integrated systems. The last step in those scripts is just push everything to Sift, right? Once that data is there, it makes it really easy to collaborate. We've used it for everything from anomaly reviews to nominal checkouts, and now we're actually using it to look at our data coming down from space. One of the things I emphasized to Karthik when we were just starting off our collaboration with Sift is how important being able to use this type of tool for anomaly review is. A lot of people don't know this, but one of my first projects I ever worked on was CRS-7 at SpaceX, and that was the only Dragon spacecraft that SpaceX had ever lost on ascent due to a Falcon 9 anomaly. So I was introduced very early to a very rigorous anomaly review process and how important data was in determining root cause, right? Time synchronized, very easy to review, very easy to collaborate on. And so really important to me was making sure that Sift would have those features, and it's grown well beyond my wildest expectations in that regard. We've used it to solve some of our most complex anomalies in test, where we have multiple sources of data that all need to be very strictly time synchronized so that we can understand the sequence of events that happened leading up to the anomaly. So for me, how quickly Sift was able to implement those features and how intuitive they are to use have been really, really impressive and surprising even to me. One of the most impressive uses of Sift has been repeated data reviews. So obviously we want to make sure that engineers are always looking at data and that it's very, very easy to do that on a continuous basis. So leading up to our first mission, which is now successfully operating in space, we did a lot of data reviews both leading up to that mission, and now we're doing weekly data reviews of all the data coming down from space. And Sift's made it really easy to build kind of standard views that we can look at, all the same telemetry channels that we want to look at every time in a consistent basis, meaning that all the responsible engineers need to do is come in, look at the same exact view that they looked at the week before, make sure nothing changed, right? And a lot of time in space is spent with flatlining telemetry, right? That's what you want to see, is flat lines across the board. That's generally nominal. So for me, Sift making it very easy to do that has been a really, really important superpower so that the responsible engineers can focus on kind of the hard day-to-day problems, and just viewing telemetry in a standard way is already solved. Yeah, I think just speed to root causing things, right? What I found is that in previous anomaly reviews, when we had an issue and we're trying to get to the bottom of it, we were really hampered by somebody needing to take a CSV file, post-process it, using a Python script, try and generate the plots on their own, then try and time synchronize that with maybe external data. That all takes time, right? And during that time, it makes it very hard to make actionable next steps to figure out how to resolve an issue and move forward. And so I think the speed at which we've now been able to work through some of these challenges because of the data that we have and the telemetry we have available has been the most noticeable delta. So I was a big user, a power user of Borg and a few of the automated data review kind of tools that SpaceX built from a tool called Hyperion and others. And so I was very familiar with what that looked like, right? I was one of the people who helped inform some of the features that got rolled into the internal tools at SpaceX, given I was a big user of those data review tools. Karthik and the team have a lot of experience with space operations, with all the various things that a company like us needs to be able to do with their data. And so baking those into the baseline feature set has been important. But then, what's really improved is seeing how our engineers have engaged with the Sift team to continuously add features, right? I always say this is kind of the superpower of a lot of the tools that were developed at SpaceX. It was the feedback loop between the engineers who are working there and the people developing those tools. And we're seeing a similar thing with Sift, where a lot of our engineers are going above and beyond to try and work with the Sift team to implement new features and make the product even better for everyone. What I like to tell all of the vendors that we work with sometimes, both on the hardware side and software side, is that you're not necessarily competing with other vendors, you're competing with our perception of what we can do ourselves, right? That's how we operate at K2, just given the talent we have, right? We have the ability to do those things. At the same time, we need to be very selective about what we choose to apply that energy to, right? Really, we want to solve the problems that only we can solve. So there's a certain category of things that might be general purpose where if we were to solve it here at K2, it would be solving a general need and a general use case that's not really specific to K2. And so I'd rather have the team of software engineers that we have where you never have enough software engineers to do all the work that you need to do, focused on the really hard problems, the software running on the vehicle, the infrastructure to really test that software rigorously, and assume that telemetry is kind of a solved problem with Sift. I think that the teams really appreciated that the tool is very intuitive, that features are being rolled out on a very rapid cadence, that our feedback is being incorporated, right? I think that's been one of the most interesting things to see even people who've never used Sift before or don't know the Sift team personally kind of get on-ramped into our company and start engaging with that team and that support team right away. And so the sort of augmentation of feature sets over time and the speed at which we've gone from some of the very basic telemetry viewing to now the more advanced features that we're starting to use has been pretty impressive. Probably a lot of Python plots, unfortunately, and that would not be very fun. I think a lot of our kind of in-house test infrastructure that we're building is now being integrated pretty seamlessly with Sift. When we kick off automated test runs into our hardware-in-the-loop environment, our flat sat, all of that data naturally goes to Sift. So we'd have to go in and kind of rework a lot of that to use maybe internal tools that wouldn't be quite as good. And we'd be much less feature-rich than we are now in terms of how we interact with and view telemetry. I think very responsive from what I've heard from the team that's engaged with them. I think the big thing that really helps is there's a lot of alignment on the basics, right? There's not a lot of debate over whether a feature is a useful feature or not. We can skip right to the part of the discussion where it's just when do we implement it, right? And that really makes things powerful. And I think that comes from a lot of shared experience between the Sift team and the developers there and our team in terms of running space operations. It's honestly hard to even visualize the superpower that you get as a company when you have every engineer engaging with telemetry, right? So if you look at some of the more legacy companies, I've had customers come here, look at how we're interacting with those telemetry systems and say they would have moved 10 times faster if they had this, right, in their integration floor, in their clean room. And so what I would say is that really consider those places where if everybody had access to data at their fingerprints, how much faster could you move? And that's really, the biggest improvement that I've seen across the industry, with people starting to adopt tools like Sift. One of the really interesting things for us is we're not trying to build one satellite, launch it, and operate just that satellite for 15 years. We're trying to build hundreds of satellites, operate constellations for decades, right? If you think about the amount of data that's being generated by those constellations, those satellites that are always up there continuously, it's an enormous amount of data, right? So what I'm really excited about down the road is a couple things. One, where we make operations super easy because Sift is able to automatically tell us when our telemetry channels are out of bounds. We're able to really integrate that seamlessly into automated operations. I think the second thing is putting our data to use for us, right? Figuring out what kind of insights we can generate on how the constellations are operating. Closing that feedback loop with the design team and saying, hey, the data suggests that this would be a more optimal design, right? Based on the thousands of satellites or hundreds of satellites that we have, really using that data to make informed changes, informed decisions on our spacecraft design.